Okay, I'm going to walk through the steps for our terrain analysis or topography lab. Terrain analysis is a subset within topography. But what I've done here is you can see I've set up my lab folder with originals, and I've got our two DEMs. I'm going to go ahead and bring them in. Okay, and you can see that Esri is displaying everything in geographic. That's a hint that these are in geographic. So if we go to source, do raster information, I can see, okay, there's my 10 meter per pixel DEMs. That's a good thing. They're 32-bit. That's a good thing. Floating point, I should say, 32-bit. And the spatial reference is WGS or GCS 1983. So since there's no projection mentioned there, that means that this data is not projected, so it's in geographic, which is why Humboldt County also looks kind of squished, right? So we're in a geographic projection, which is just not a good representation of the Earth. But we're going to leave it this way for a little while. Now, for this analysis, we want to do most of Humboldt County because we're looking for a good place to have a homestead after the zombie apocalypse. So first thing we need to do is mosaic these together. And so to do that, Mosaic to new raster. As I mentioned before, I'm going to give you the names of these tools. You want to write them down because some of them are not at all obvious. There's a mosaic tool, but that mosaics a raster into another raster. For my inputs, I'm going to give it my two rasters. You can do more, but don't do too many because Esri doesn't like it. When we put in a lot, it will tend to crash more. And I've had a number of crashes, just so you know, going through this lab. Okay, find my folder. There's lab 10. Now I'm going to go ahead and put this into working, remembering that this is geographic data. And I'm just going to call it mosaic.img. Oops. Oh yeah, some tools want a folder and have you separately specify the name. Now I'm not going to change the spatial reference at this point, but I am going to change the pixel type because for some unknown reason it defaults to 8-bit, which is bad because that's going to just totally screw up our DEMs. It's a DEM, so there's only one band in it, our elevation values, and you really don't have to worry too much about these. This is just what it does if it finds values that overlap, like here in the middle. You might want to pick mean. I tend to just leave it the way it is because that tends to be best in Esri unless you need to change things. Okay, this is going to go ahead and mosaic two rasters together into a new one. And periodically I am going to pause, and through the magic of computers, our mosaic is now done. Yay! Okay, now before I go too far, I want to find out if there's any artifacts in here. In fact, I actually ran a hillshade before I did this because I checked each of the rasters individually for hillshades, and then I mosaiced and I did hillshade. I do want to work in UTM Zone 10 North. I want to work in a projected system because we're doing calculations, slope and aspect. But I'm a little nervous about hillshade, so I actually ran them. So I'm going to go ahead and project. But like I said, I recommend doing hillshade before you do this, because I did. But I'm going to try and speed up the video a little bit because you guys can start and stop it where you need to. There's my input raster. Now my output. I'm going to go ahead and put this in working, but I'm also going to create a new folder for my UTM Zone 10 North data, because everything I put in this folder is now going to be UTM Zone 10 North. Okay, does it want a file name? Let's say I want a file name. I can call it the same thing. Here's my output coordinate system. Go ahead and pick one of my favorites, UTM Zone 10 North. Geographic transform was put in for me automatically. Remember to pick a sampling technique. Bilinear, cell size got picked up automatically. Great. We're running, and through the magic of television, that looked like it ran really fast. It actually took several minutes. Now notice I've got two images over here called mosaic. Not really what we want to have, but let's go ahead and check. Our cell size is still okay. It's still floating point. we scroll down, though, you will see the spatial reference is now UTM Zone 10 North. Now, a good thing to do is to go ahead and get rid of everything we are not going to be using anymore. And I'm going to go ahead and change the spatial reference / coordinate system for my map to match my layer. There, now Humboldt County looks better. Okay, the other thing is that this created a rather large raster. So if we go into my working folder, a little bigger, you will see that, oops, this raster is about 500 meg. Nah, it's getting a little bit big, both for Esri and also for speed. So in my originals, I put it in here, I have a county data set just off of the Humboldt County website. Failed to add it. Okay. Why did you fail to add it? Well, that's just annoying. I don't think I have anything running that should do that. So I'm not really sure what happened there. I did have to reset ArcGIS Pro several times, but let's see if we can add it this way and keep going for a little bit. Maybe it's because I copied it. Oh, there it is. Aha, did I copy the whole thing? Or did I miss something? I missed the DBF. Oops. Make sure you get all the files that are associated with it. That's what happened. Now it works. Good deal. Okay, to go ahead and crop a raster to a shapefile, we need the extract by mask. You might have thought it would be called clip, but that would be too consistent. So it's called extract by mask. That's how you do it for a raster. Toss the raster in there. Toss the county layer in there. Give it a good name. I tend to just add the operation that we did. And we can run that. And now we have a dem of just within the county, which also makes it look nicer. Okay, we didn't get the whole county, but that's okay. We've got the area that we're interested in. And again, I'm going to go ahead and get rid of that. And then I'm going to go back over to my lab and make sure I'm following the instructions. Now, before we do anything else, before we're doing analysis, I'm going to go ahead and run a hillshade. That's what I forgot to do. Now, when I went through this lab before, I actually did this at every step since we've been having issues with hillshade rasters, or with DEMs having artifacts in them. I ran hillshades regularly, can just leave everything alone, and made sure that they looked good. And you can't do enough hillshades to look for artifacts, in my opinion. All right, so there's our hillshade, and looks pretty good. You want to zoom in. Ooh, actually it looks great. Now we've got some artifacts in here, but notice that they're not like straight lines or anything. So those are in the original DEM. And in fact, it's good to check as soon as you download the DEMs. These funky lines that we're seeing are actually artifacts in the DEMs. We're not sure why the 10-meter DEMs have them, but there they are. So we have to deal with them, but they're not too bad. And since they're not systematic, they don't tend to mess up things as much as if we did projection with like nearest neighbor. Okay, so I think we're in good shape. So now we can get started doing some terrain analysis. So let's start with slope. Okay, now with slope, we're going to take our input raster. Whoop, not the hillshade. Okay, good name for our output raster, like slope. Make sure it's degrees. Now the Z factor, important here. We need to know what the units of this data are. And there's a couple different approaches you can take, right? So right now we don't know what units the elevation values are in. If we go to the metadata, is it in the metadata? Well, I'm going to let you check. You could also just go in and using the map, find some point that you know of and say, that point is at 167 and look on a topo map. Or you could also, go into the original DEMS and it might be in there. So somewhere there's data or information about the elevation units. If the elevation units, in other words, the height values or the z values, match the horizontal values or the x and y, okay, then you can leave the z factor as a 1. Since we're in UTM, that's always in meters. So hopefully this is in meters. And off we go. And there's our slope raster. And if we zoom in, you can see it has this really interesting characteristic to it, right? It's kind of cool stuff. Now also notice that Esri's symbolizing it with light values where it's flat and dark colors for where it's steep. Okay, so we've got steep spots. Now these things that look like streams could be streams. Those look like they are, but also notice our ridges are also light colors because they're flat. Streams are flat. It's the in-between areas, the slopes between the ridges and the streams that are getting the higher values because that's where the higher slopes are. Okay, kind of fun. Now we want to do is we want to find the slope values that are greater than 1 and less than 5. So for that, we need Raster calculator. And we can take our slope, and if we just wanted to find the areas that were greater than 1, we could do that. However, we want to do them both. Now, I don't recommend writing very complex equations in Raster Calculator. I recommend doing it one at a time. But in this case, this is fairly simple because we're going to do slope greater than 1 and less than 5. And yep, believe it or not, that ampersand is an and. Sometimes in ARC they use the word and like in the field calculator, but here it's an ampersand. Not a great symbol, sorry about it. And so I'm going to call these gentle slopes. Okay, because that's what we're looking for. For our homestead, we don't want something that's flat because it would get wet, be a swamp. We want some a little bit of slope, especially we can go grapes, make wine, but not too steep because we want to be able to build buildings on it. So I'm going to run that. Now what's going to happen is it's going to run a Boolean equation. In other words, it's going to find the slopes that are greater than 1, and it's going to, in the background, create a raster that has 1s where the slope is greater than 1 and 0s where the slopes are less than 1 or equal to 1. It's going to do the same thing for less than 5, and then it's going to AND them together. In other words, we're going to get the slopes, and if you take a look, where we ended up was along rivers, okay, where there's gentle slopes, not the rivers itself, which would be flat, okay, but nice gentle slopes, and found them all over the place. Okay. Now you may find some artifacts in some of these rasters where you see a whole bunch of little lines. This one looks like it came out pretty good. And if you do, it's probably because of the resolution of the raster rather than something that's real going on the ground. Okay, so that's our slope. Now we're going to do aspect. So we need the aspect tool. Okay, aspect is very simple. Just make sure you go back to your DEM and then make the output a good name like aspect.img. Leave it as planar and off we go. And there's our aspect raster. Now it looks kind of strange and wild colors. And if you look over in the legend, you'll see it's actually going from 0 to 360. So I'm not sure why they symbolize it that way. I think it's kind of strange. I just change it to stretch so we can see all the values. Now you can kind of see some of the subtlety going on. Where it's going to go from 360 to 0, right? It's going to be kind of weird, but otherwise it looks kind of nice because it's giving us the direction. And it's going to go from 0, where the aspect is facing north, all the way around. And what we want is we want to get the south facing areas. So for that, again, we need Raster calculator. Ooh, can even misspell it a little bit. And we want to do where the aspect, excuse me, is checking, there we go, between 135 and 225 degrees. Aha! So that means I need to go greater than 135 and notice I always double click up here on the file name because then it pastes it in with the right quote, so I don't have to worry about that. And 225 degrees. All right, and then my output raster can be something like south-facing. Whoops. .img. Okay. And there we go. Now, what we're going to do next is create what we call a simple model. Okay, and this is really a very powerful technique that we're just going to do a very simple one of. So we're going to take our gentle slopes, and we're going to multiply them times our south-facing slopes. And out of that, we are going to get our candidate sites. Okay, if we run that, what it's now going to do is multiply them together. So we've got areas where there's ones where there's the right aspect and ones where there's the right slope. Multiply them together, that means the areas that will be left are those areas that have ones in both places, or the slope we want and the aspect we want. Now you could do this with all kinds of different parameters, the right precipitation, the right soil, the right distance from roads, whatever it is you need, and then multiply them together and boom, you've got a raster layer that shows you where those places are. Okay? So, very powerful technique. It can get really complicated. Okay, so we've got our hillshade. Do we have our hillshade? There's our hillshade. I'm going to go ahead and turn off some of these layers. Keep them around just in case I messed up. Here's our candidate site. So one thing to do is to go ahead and zoom in somewhere. See, okay, we're thinking in here, we should look at our hillshade. So does that make sense? Well, those definitely look like they're south-facing, because this is south-facing, and they're not completely flat. So yeah, it looks like we got the right area. Okay, and then we're going to keep going. We want to do some analysis on this. So we want to convert it to raster, to a polygon. But first, we probably want to get rid of some of these values because all the zeros will actually be converted to a polygon, which is kind of annoying. So we can do that quickly in reclass and take our input raster. And what we want to do is with our new values, we want to take our zeros, convert those to no data, and now we can say candidate sites. I'm just going to call that candidate sites only, unless there's a name in there for it. I don't see one, so seems like a good name. Okay. And did that work? Oh, it did. Esri just picked a really poor color choice. Oh, there we go. Double click. There we are. Okay, so yeah. That's still not a great color choice. Let's do something nice and bright. There we go. Now we can see our sites. Okay, cool. All right, now we can go ahead and change this to raster polygon. And there's lots of ways to solve this problem, honestly, and some of you will do it a little differently than I did. That's okay as long as you come up with the right answer. You could convert the whole thing to raster to polygon, and then you just end up with this one really big polygon, which is kind of annoying. Okay, now, do not simplify polygons, right? If we simplify polygons, it'll smooth them out, which looks better, but we're going to run an area calculation, so that will make our areas incorrect in comparison to the DEM, right? The whole world is made up by 10 by 10 pixels for the work that we're doing, so we need to stay with that all the way through the process so that we're good and consistent with what we're doing. Okay, while that's running, let's see what the next step is. Just going to calculate area. We've done this before. Did it work? Yeah. Can't add site polygons. Cool. Let's go to our attribute table. Add a field. Call it area. Double. And go ahead and calculate that. Area, expression type. Oh, whoops, I'm sorry, I picked the wrong tool. Calculate geometry, there we go. We want to compute area. Don't need to specify the coordinate system. I'm going to work in square meters. You can work in square hectares, or you can work in square meters and divide it by 100,000. And it's a big polygon, so big polygon shapefile, so it's going to take a while. And that took kind of a ridiculous amount of time. Okay, but look, we got polygons. Now I'm going to pick this one, which is not really, ooh. Oh, sorry. I forgot to sort descending. There we go, that'll help. All right, now rather than pick that one, I'm going to pick the next biggest one, so you guys don't know which one it is. Ooh, looks like we got a nice little spot by the river here, looking pretty good. Okay, I think I like that. You guys want to pick the biggest one as part of the lab. But now what we're going to do is we're going to run a view shed. So view shed is very different, and because we want to be able to see the zombies coming, we need to build a tower. So we need to see how big we need to make our tower. We'll run the view shed tool. Now before we run it, notice it's looking for an input raster. That's our dem, but we need a point for where our view shed is going to be, or where our tower is going to be. Now you might put it up here, but that might change it. So I am going to run a feature to point. And what that will do is that will convert my feature. Oh gosh. Keep forgetting these steps. I need to watch the lab and make sure I go step by step. I need to export my zoom, export my selected feature to a new layer, so I am just working with it. There we go. Now I can go ahead and do, that is my input features, and I can make this my lookout tower. Okay, run that. Oh, and I forgot to click inside, so it put it outside. Not sure why it did that. Oh, actually I am. It finds the center of mass. So because the center of mass here is outside, I really need to check inside because we want to have it inside the compound that we're going to build. Okay, so now we've got a point in there. Now we can go ahead and run view shed. We need our input raster, which we got to go all the way back to our dem. Same one we've been running the whole time. Put in a lookout tower. We're going to call this view shed 1. Okay. Now again, if our elevations are in meters and our horizontal coordinates are in meters, we're okay. Don't worry about earth curvature. You only need that if you're doing a really big area. And we're going to run that. And it's going to take a while. And we have a view shed. So I should close this. Now, the problem is we can't really see very far. In fact, it's kind of strange that we can't see down here. We can see the hills that are behind us and in front of us and over here. You can even see some hills that are above here, probably being able to see over this ridge to this area. In fact, you'll notice that you can usually see some areas that are quite a ways away because these are mountain peaks that are well above us, so they show up. But we can't see anything down here. It's like, well, what's going on? Well, the interesting thing is that the way this tool works is it assumes that you are right at the surface of the Earth. And to fix that, what we need to do is we need to go into our attribute table. You have to add an attribute called offset A. It has to be that value. There's actually a series of values that you can input into your attribute table, like that one. And then you need to type in a value here. So let's make our tower 300 meters tall. Now, here's a problem. You need to hit enter to get these values to stick. And they actually locked up on me and I couldn't get it to stick, so I restarted Arc last time I did this. So just be ready for those kind of problems. But I think that one took, and even if I go back, yep, they're there, and I have an extra thing here which I really don't want, so I'm just going to go and delete that row. Okay. All right, now we should be able to run this. And I'm going to do this and say we're running this one, run a scenario at 100 meters above the ground. Oops. There we go. Okay, and now suddenly we're able to see down our stream, and we can't see over here. We might want to go a little bit higher or maybe try a different location, but there's our view shed, so looking much better. And that's it for this lab. Light color. Dark colors. Light colors.